All right, so we are adding and subtracting rational expressions. We're gonna start off easy. Do you remember how to add fractions together, like normal fractions or just numbers?
Yeah.
I'm so sorry.
Like have the same denominator.
Right, that's a big deal, whether they have the same denominator or not. So just grab a page here. So I actually want you to just start off by seeing all right. This is 6-3. All right, so first, I want you to try some old stuff. Do you remember? How do you add something together like, oh, I don't know, how about 2 7s plus 3 7s? Super easy. That just becomes 5 7s, right? So remember that if the denominators are already the same, you literally just add the numerators together. So that just becomes 5 7s. Easy peasy. If the denominators do not match though, things are a little bit more inconvenient. So if I had something like, oh, I don't know, how about 2/5 plus, I don't know, 4/9. Oh, bummer, I don't have common denominators. So actually, can I change this? Change this for 1 second. I want to do 2 different style ones. Change this to 4 out of 15. Sorry. So in this case, I still don't have common denominators, but what can I do to get there? I can multiply that first fraction by 3/3 to get it to have common denominators. So I turn it into 2 fractions that have common denominators by doing that. So now I have 6/15 plus 4/15, which I can now, oh, I wrote 19. Oh. Or 15. There we go. So now when I add them together, I do have common denominators. I get 10/15. And then don't forget, we can reduce that fraction, right? So that's going to reduce down to be 2/3. And there's my final answer. Sometimes I have a situation like the first example I actually wanted to show you. Say I had 2/5 plus 4/9, I think it was. So in this situation, I can't just multiply one fraction by a number, but can I multiply them both by something? Yeah, so what's my common denominator going to be with 5 and 9? What would my common denominator be for 5 and 9? 45. So in this case, I'm just going to multiply this one by 9/9 and this one by 5/5, right? Okay, this is old news, but it actually works the exact same way when we are turning them into rational expressions. So I got 20/45. And now that I have common denominators, notice the denominator does not change. 38/45. Does that reduce? I don't think so. So I think I'm done. So you remember how to do this with normal numbers, right? Right? We're doing the same thing. It's just going to be a little weirder. All right. So let me give you some how-tos on here. How to add rational equations or rational expressions with common denominators. Those are really easy. First, we're just going to add the numerators or subtract, I guess I should say, if it's a subtraction problem. keep the denominator the same, just like we did with regular numbers. And then, once I've done that, then I reduce if I can reduce. Reduce if possible. That's it. So when things are the same, life is really easy. So if you look at the worksheet that I gave you, looks like 1 through 12, they're all the same denominator. So let's just do, I don't know, the first one together. I'm going to rewrite it on here, but you could do it on your sheet if you wanted. So the first one says k minus 1 over k squared plus 2k minus 24. And we're going to add to that k plus 1 over k squared plus 2k minus 24. So lucky me, I already have common, I have common denominators. It's already ready to go. So I'm literally just adding the numerators together. So what do you get when you add k minus 1 plus k plus 1? What comes out? Add all that together. What's your answer to the numerator? 2k. My minus 1 and plus 1 are going to cancel each other, and then I have k plus k. I just get 2k in the numerator. Do you see that? If I just add those together, and then the denominator just stays the same. I just leave it as k squared plus 2k minus 24. I do have to check to see if this can be reduced, but I can tell you right now the answer is no. How do I know that? Because look at the denominator. Maybe that does factor, but it's not going to factor into, it's going to be two binomials, right? It's not going to be anything that cancels with 2k. I can't pull a 2k out of the whole thing, or just a 2 or just a k. So this does not factor, or it doesn't reduce any further. So even if there are other factors, yeah, positive 6 and negative 4, doesn't matter. So if I already know that it's not going to cancel, I don't need to bother. Like, you don't have to give me your answer with the bottom factor. You can, it's the same thing. That's not going to do me any favors. Does that make sense? Now, I want to try a subtraction problem because you got to watch. So let's do another example, like number 3. 4x minus 3 over 3x to the 4th plus 12x to the 3rd. This time we are going to subtract x minus 2 plus 12x to the 3rd. All right, so everybody please watch. Please, 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 please. This is a subtraction problem. My denominators match. Great. So now all I have to do is subtract the numerators. You have to be careful. You are subtracting this entire numerator. So it really is negative x plus 2, right? Because you have to subtract both of those. So sometimes with subtraction, here's what I like to do. I just kind of rewrite it up here. I'm really doing 4x minus 3, and then I'm just distributing that negative. Minus x plus 2. So now I kind of have this, and I'm just going to combine my terms. So I'm going to get positive 3x minus 1. Do you see how that works? You have to make sure that that negative 2 that was there actually turns into a plus, because you're subtracting the whole thing. That is such a common mistake. Kids will only subtract the x and then leave that 2 as it was. You can't. You have to subtract whatever that numerator is. If there's 3 pieces, you'd have to distribute the negative to all of them. So be real, real careful with the subtraction, okay? And then in the denominator stays the same, 3x to the 4th plus 12x to the 3rd. Can this one cancel? Well, if you're not sure, I can factor the denominator. So in the denominator, I can take out a 3x to the 3rd, and that would leave me with x plus 4. So could I cancel anything with 3x minus 1 and this? Does anything cancel with that and that? No. So it doesn't matter if you leave your answer like this, or if you had already factored it and you left your answer like that. It doesn't matter. They're the same thing. But I don't have to do it because in this case, nothing cancels. But if something does cancel, you do have to do it. Okay, why don't you try? Let me give you another subtraction one. How about try 8. Hello! Oh my gosh. Well, thanks. Hold on, I have things to give you. We're looking at this right now. Did you already, you probably didn't get, hold on. Did you already get one of these? Were you here for this?
No, I didn't get that.
There you are. Oh, welcome. Okay, everybody's got an answer? All right, so this is another subtraction one. You gotta subtract both of these things. So I hope what you did was 6 minus x plus 3. And then combining like terms, that's gonna get me a 9 minus x, or maybe you wrote it as negative x plus 9. Either way, it's the same thing. I would probably put the negative x and then the plus 9. But if you have 9 minus x, same thing. And then the denominator, 3x plus 3. Can I simplify this? I'm gonna go with no. I could take a 3 out of the bottom and that would leave me x plus 1. And since nothing there cancels with anything up there, no, in this case, that does not reduce. So that's my final answer. Okay, so when denominators are the same, pretty easy, right? You just gotta be careful with the subtraction. Are we ready to talk about when they're not the same? Okay, great. I like the enthusiasm. So I got to flip. All right. Oh my gosh, I have so many papers in here. So when denominators are not the same. All right, so our rules change a little bit. So we're going to do, I'm going to look at an example at the same time. Let's start off with something. I guess we can start off with one of the super easy ones. Well, anyway, let me give you some how-tos and then we'll do some else. So first, factor your denominators, not the numerators. I don't care about the numerators. I want to factor your denominators. Denominators. There we go. Factor your denominators. So if your denominator has something that can be factored, factor it. Then you're going to determine the common denominator. And then just like when it was normal numbers, once I'm like, okay, like in that example we did before, we figured out the common denominator was 45. Then I just got to figure out, okay, so what do I got to multiply every fraction by to get them to have a denominator of 45? So once I figure out what that common denominator is, I'm just multiplying every fraction that I need to by whatever it needs to get that common denominator. All right, so that's what I'm doing in step 3. Multiply any fractions by what is needed to get common denominators. And then once you're there, now it's a problem like before. Now the denominators are the same. I just add the numerators and I go about my day. Okay, so I'll just say proceed as usual. By adding or subtracting, if it's a subtraction problem, numerators. Keep denominators the same. And lastly, simplify. So a little bit more involved when we don't have common denominators, but we're going to start off easy and then we'll work our way up to some tougher ones. Let me find a good first one to try. Oh, okay. Let's start off real easy with something like 16. So 16 looks like this. A minus 4b over 3 minus 4b over 3a cubed. Okay, everybody with me? Yeah, we're good? Okay, so step one is to factor the denominators. There's nothing to factor here. So step one, I don't have to worry about in this case. Step two, what will the common denominator be? 3a cubed. So I'm gonna have to multiply this one by just a cubed over a cubed. If I do that, then my denominators will match, won't they? Yes, so I'm gonna multiply by a cubed over a cubed. Now, you need to be careful though, because when I multiply the numerator by a cubed, the numerator is a binomial. So I gotta distribute that a cubed to both of them. So when I do that, it's gonna look like this. I'll have a to the fourth minus 4a cubed b all over 3a cubed. Yep. Go so fast, oh my gosh. Does that first chunk make sense? Do you see how I arrived there? And now the second one, we got lucky. It already has that common denominator, so it's already good to go. 3a. So now that I have common denominators, now I can just do the subtraction. And I'm lucky here, it's just a, I don't have to distribute the negative because there's only one thing, right? So I'll just be minusing the 4b. So when I put all that together, let's see, I'll have a to the fourth minus 4a to the third b minus 4b. And that whole thing is going to be over 3a to the third. And then I just asked myself, can I simplify that at all? I don't think so. I can't take an a out of the whole numerator. If I could, then I could get somewhere, but there's, I don't see anything I can do, so I'm done. Does that make sense? Let's try another one that's maybe a smidge tougher. How about something like 26 looks great. All right, 26 has k plus 1 over 2k squared minus 4k. We're going to minus from that. Oh, you know what we could do with this particular one to just make our life so much easier? Look at this. Can't you just reduce those threes? Right? Couldn't I? What's stopping me? 3 over 3? Let's do that. That makes it so much easier. Okay. So step one, factor your denominators. This denominator can be factored. Couldn't I take out what, 2k? Why 2k? You get it? I was live for that. You guys don't even know.
You were what?
I was alive for Y2K. You even know what Y2K is?
Yeah.
Oh.
It's an aesthetic, like.
We didn't know when, this is what they told us. They said that all the computers like weren't gonna know how to handle 00 as like the end date. They were like, are the computers gonna think it's 1900 and like cease to exist? I don't know. They thought that all the computer stuff was just gonna go haywire. It did. It was fine. But I remember I was at New Year's Eve party and they shut the lights off to try and scare us, but then they turned right back on. I was like, oh, okay, that's no big deal. But everybody was hyped up about it. Anywho, so we factored that. Okay, that's done. So step 1 is now done. I factored the denominators. Now I need to figure out what the common denominator is going to be. So this one, I'm going to cross these 3's out a little bit more clearly because they are gone. This one's just a K. This one's a 2K times K minus 2. They both have K already, right? So that's one thing that they already have. Yes.
Can you distribute the 2 and then multiply it times that? So it'd be 2K minus 4. And then
Well, we had that and then we didn't want it.
no, without the other K.
You mean multiply this one by that? If that's what you mean, you're right. Yes, they both already have K, but this one does not have that 2 or this K minus 2, right? This one's missing those things. So I'm going to multiply this one by those missing things. So it doesn't have 2 and it doesn't have K minus 2. So now look at my denominators. Don't both of them have a 2? Yep. Don't they both have a K? Yep. And don't they both have a K minus 2? Yes. So now I have common denominators. So it's up to me now. I have to do the operation up on the top. So let's write this a little bit neater and figure out where we're at. So my first fraction really hasn't changed. I still have K plus 1 over 2K times K minus 2. All right, minus this one, I do need to distribute that. So that's now going to be 2K minus 4. And then in the denominator, I'm going to have 2K times K minus 2. And now it's a problem like on the other side. Common denominator. So now all I have to do is the operation on the numerators. You see that? It's a subtraction though, so be careful. So we're really going to do K plus 1 minus 2K plus 4, right? So when I write it all, combine my like terms, I'm getting negative K plus 5. And there is my answer. Let me give you one to try. How about 21 looks perfect. You try 21 without me talking you through it. Yes.
Okay.
Hello. Let me give you this sheet. Thank you. Hello. Oh,
I love it.
thank you. Let me do
I feel like
this.
Thank you.
You're welcome. Okay, were you able to make some headway on this one?
Wait, can you just give me like
Sure. All right, step one, factor the denominators. So nothing to do there. Here, I could take out a 3, couldn't I? So now I take a step back and I look, oh, they both already have a 3. That part I don't have to worry about. But this one is missing the 2k minus 3. Do you see that? So let's go ahead and multiply this first fraction by the 2k minus 3 that it needs. So when I do that, in the numerator, I have to distribute that, right? So that's now going to get me 8k squared minus 12k. That's the numerator. In the denominator, I have the denominator, you don't have to multiply that together. You can if you want, but why? It's the numerators, you have to do it out because you're going to combine like terms. So there's what I have. And now I have common denominators. And now it's just an easy problem like it was on the other side. So let's just combine like terms in the numerator. I'd have 8k squared minus 11k. And then a plus 5 all over that.
So okay, we have like over 6 minus.
Yeah, you just did more work than you had to.
Well, I didn't even. Take this from the-
Oh, you didn't
Yeah,
do that?
but I got 2k minus 3 still.
Oh,
I looked at it and I realized you had to multiply 3.
Oh.
with 2K.
so you did it.
Yeah,
You just did it in your
I
brain.
didn't write it.
It's fine. Same thing. I should be checking if this last thing can factor, but I'm pretty positive that, yeah, I could, maybe I could. I should check it. So I'm just going to try and factor that numerator real quick. So are there factors of 40 that have to be negative 11? Five. I don't think so. So I don't think the numerator factors. So I'm safe. I should be. Right? Am I wrong? Are there factors of 40 that have to be negative 11? No, right? No. Yes? No? I don't know. You guys are not being helpful. I don't think there are. So I think I am.
How's your life?
Bad now? Oh
I
my
don't know.
gosh.
Bad. You know.
All right. So that's the gist. The only way that you're going to get good at these is by practicing them. Yeah? Is everybody okay with the concept?
Yeah.
So we factor, we add.
Please pardon the interruption. Anthony Laborante, report to the check office. Anthony Laborante, report to the check office.
We're going to try this one. Why do helicopters get sick so often? This is page 120 in your little puzzle pack. I like this because you'll know right away if you're doing it right or not, because the answer is either there or it's not. Okay? I do not recommend that you try and squeeze it in on this little tiny piece of paper. If you want paper, you can have some paper. I don't care. You need some room. You need some room.
Wait, why can't we do this one? What was in this meeting else?
It's too easy. Yeah.
There's one in that one.
Yes.
So that's like, we're gonna bring another sheet, please.
Can we do the what lives in the sea for extra credit? Should not be.
Thank you.
Welcome.
This paper for extra credit.
I bet if you do it, it'll make you better at this topic and you'll ultimately get a higher grade. So essentially, you're giving yourself. Exactly. If you want more paper, I'll leave it right in this basket. You can take whatever you want. I will open this on Jupyter in just a moment. Yes. It's my scrap paper, so I only use one side.
It's like, we can use the side.
You sure can.
Thank you.
You're welcome. Yeah. Bet you I made a video.
On Tuesday, but I had, yeah.
Jimmy.
Um,
Oh, I got it.
yesterday, we did.